Hybrid Cloud Show, Episode 17. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. All right, so today I have a question for you all. I would like to know what it is, the 2 or 3 things that are currently most annoying to you about working with existing cloud tools. Or on the flip side, what would be on your cloud tools wish list to make your life that much better?
Some kind of service parity between the clouds would be nice. Like building something that uses managed OpenSearch or managed Elasticsearch or something, and then finding out that I need to deploy the project in Azure, which has no functional equivalent. Kind of annoying. So for me, that is probably the most irritating thing, is that there are not services that do the same thing in an API compatible way across all the clouds. Although I guess that really that's the USP of certain clouds, right? If everywhere had S3 compatible storage, maybe it would be a way less competitive market.
And would you want that at the API layer?
Not necessarily at the API layer, but an easy way to build it in a way that I don't have to manage would be nice.
Isn't that just called self-hosting? Deploy Redis on your own, and then as long as it's in Kubernetes or something, then it's just the same everywhere?
Maybe if I twist it a little differently, like I had in my mind, like new open standards. I think S3 is a de facto standard for object storage, but it wasn't some open standard that Amazon altruistically shared out there. It just happens to be pretty good at what it does. Imagine we had the same thing for functions as a service or IAM standards or networking in VPCs, for example. Like it would shave off so much headache with trying to load your head up with the count of concepts you've got to hold in your mind when you're thinking about different cloud technologies would really reduce the barrier for that. And probably like S3 would just deliver a lot of excellent tooling. Like lots of providers are S3 compatible, lots of clients are S3 compatible, lots of libraries. It's really, really nice. And you see the pain of that in dealing with everything else in those clouds.
Yeah, I think that's kind of what I'm getting at, Shane, is having to reinvent the wheel for a bunch of different services that, like Sean said, I could go and deploy myself, and I could manage an OpenSearch cluster or manage Redis myself. But the beauty of deploying in a cloud provider for me is that all of those things that for the most part are just some undifferentiated product that I need a connection string for and I need to point my application at, if they had a set of open standards that everything adhered to, or even a set of common standards, right? They don't have to be open. The cloud providers can agree to keep that proprietary for all I care. Just a set of services or a set of things I can target that mean that I could easily deploy across clouds would be great.
And ideally, how would you want to interact with that? Like, what would be the way that you would ideally ask for that OpenSearch or whatever and get it back in a useful way?
I mean, it wouldn't have to be OpenSearch, but I guess for me, it would be a universal provider that I could use across the clouds that would say something like, I need an in-memory database, and there is a standard in-memory database thing. Or I need a Postgres-compatible database, and the cloud provider spins up a Postgres-compatible database in whatever way they spin up a Postgres-compatible database, and they spit back a connection string. I mean, Postgres is a particularly poor example because all the cloud providers have that. But you get my point, right? I don't care what they do in the back end as long as I get something that talks the language I want to talk.
So we want Terraform, but instead of having the specific resources per cloud, right? Just say database, Redis, just get exactly what you want. I would like that.
Yeah, exactly, right? I don't have to care as an engineer that the Azure thing is called Cosmos or the AWS thing is called Dynamo or whatever else. All I care about is I want table storage. And I say, give me table storage, and there is an open standard for how I interact with that table storage.
I think the fact that Pulumi and Terraform are businesses shows the demand for this and also highlights the limitations of these tools like Pulumi and Terraform under the hood are still managing all of the interactions with these inconsistent APIs and trying to present something consistent on top of it. But you still have to absorb some of the inherent differences between these providers that, again, you can't abstract this away because there's no agreed standard they're all working towards.
Well, and I guess something like Pulumi or Terraform gives me a standard markup to interact with those things with, but ultimately I'm still having to learn the GCP provider or the Oracle provider or the Azure provider, and those have their own idiosyncrasies that I've got to work around. In my dream utopian world, there is no provider. There is just we support these 5 big clouds, and these are the underlying things which we will deploy. Like, I just want it completely abstracted away. I want to be able to say, give me object storage, and I get an object store that I can interact with in a standardized way. I guess the argument against that is, well, how do the cloud providers differentiate? And maybe they differentiate in terms of performance or something like that, right? They build some new Postgres compatible engine in the back end that is 10x more performant than the other one. I don't know, but it just feels like I'm constantly hampered when I'm trying to deploy stuff across different clouds by having to learn what their different services, availability, and idiosyncrasies of those are.
Yeah, the promise of Terraform was write once, run anywhere, but it's not. It's write a different version for every single thing you need.
Yeah, I mean, it's learn one set of syntax and write everywhere rather than whatever else. And the other problem that you find is that a lot of those Terraform providers are community maintained. And there are certain modules within those that aren't community maintained, but if Amazon release a new service at reInvent next month, I can almost guarantee there's probably not going to be a Terraform provider for it for another 3-6 months, unless some kind engineer at Amazon happens to have written one in their spare time.
All right, then switching gears. My number one thing that I wish every cloud service would give me is IAM. I want IAM to be a solved problem and standard across all clouds.
Isn't that what we already said? Just more specific to IAM, is that what you mean? You want to solve that problem first?
Yeah, because even if there was a standard between them, let's pretend that was the thing. All the clouds go about doing IAM differently. And it can be jarring trying to go from, how do I do this in Azure to how do I do this in GCP? And then I don't even need to do an AWS because they did it for me. Learning those intricacies, those nuances can be tiring. And I don't want to be a cloud expert like that.
Yeah, the amount of times that I write an IAM policy and then I find out 6 months later that there is some inherent flaw in it, or I've accidentally given wildcard on something that I probably ought to not have, or I need to learn the 10 different get, put, whatever permissions that a certain role needs. It's far too frequent of an occurrence, you're right. I don't even know how you begin to solve that, though, because each service has its own 100, 200 different things that you can perform on it. And that varies across services, across clouds. They're all named differently. There's not much consistency. It feels like if it was a problem we solved 20 years ago, maybe okay. But we've come well past SNS and S3 being the only AWS services at this point.
If you're going to go with IAM being unified across all clouds, you almost need to inherently unify all clouds so that all the IAM policies would be equivalent. So it's a tricky problem.
I mean, heck, I still have to try and get my head around bucket policies versus IAM policies for S3 sometimes, and which one applies first, in which order. And yeah, Sean is facepalming right now.
Yeah, we're struggling with the same service, with this same policies and the same provider, and it's inconsistent. So yeah, what hope have the providers got between them?
Yes, well, it sounds like you're talking about more than the sort of OpenID Connect or whatever sort of problem. You're talking about trying to unify the underlying policies that you'd have to set in the IAM as well, which is going to be super hard if you don't have that consistency in the underlying cloud providers like we were just talking about.
It's connecting closer to real problems, I don't want to be dealing with IAM. I want to vend to a developer a database and give them a certain amount of access to do that and a certain amount of access for someone else to do something slightly more elevated, and someone else has less access. I want to do that in a very standard way across all cloud providers. That's the problem I have to solve, and many people are going to want to solve in the cloud. And it's just a nightmare to try to do that across vendors. So I think it's that.
It's tricky, right? Because like Sean alluded to begin with, on AWS, some of this is a solved problem. There are managed roles and managed policies that effectively, for 90% of use cases, give you the IAM permissions you need for something. And you can just say, yeah, I want a RDS writer or something, or an RDS read-only replica thing, so I can replicate the data off somewhere else. And those policies and those roles exist. They're managed by AWS. If they go and update what set of permissions something needs to read from a database, 99 times out of 100, they go and update the managed policy. If not, it's a bug. Please tell them and they will fix it. In other cloud providers, that doesn't seem to exist as much, and I've got to go and build my own custom policies for this thing, or go and trust some community repository of them on GitHub, which may or may not be trustable. So just standardize what the get, put, read, write actions are across clouds at the very least.
And how do you normally solve the identity problem in a platform engineering function today?
For identity, OpenID Connect probably is the way that I would do it, or SAML, something like that. Some way of backing the identity off to a known managed identity store that your enterprise is already using. Say Google Apps, Cognito, Azure AD, or
Okta.
Yeah, Okta, whatever tool you're using. It probably supports SAML or OpenID. You can back off to it as a store of users or identities.
And then how do you solve that policies piece that goes with the identity?
You're kind of describing the problem of platform engineering, which is like taking the needs of the organization and then applying them through infrastructure in the cloud. The value in platform engineering is finding generic problems within an organization and solving them generally so that everyone can make use of them. But sometimes, in many cases, it's not organization specific. It might be tech-wide specific, that someone needs a database, someone needs a certain amount of credentials. And those are the things I'd like from the cloud provider. So what you're describing now, Aaron, is the problem platform engineering solve, which is that gap between what an engineer needs to deliver and what needs to be deployed in infrastructure.
Yes, I was getting off script because I got curious. I was wondering how you do, in fact, solve these problems.
You'd wrap some abstraction layer you give engineers with scripts or CloudFormation or CDK or some other IAC tool, and that would, you've requested a database, I will provision the IAC to give you that database and the permissions you've configured that you need for that.
Yeah, that's what we've done. We've wrapped basically pipelines around provisioning different things with the correct access around stuff like Git and GitOps. So that way you can just ask what you need. If someone approves it, then it'll be provisioned for you. It's at least a step in the right direction, but then you get into problems where, for example, my team, we're doing ephemeral deployments in ephemeral environments, and I can't get those like extra databases or whatever spun up in time because it has to go through this manual process that has to be approved and stuff. So that's not feasible for me. So not quite a solved problem, but it's a step in the right direction.
So it sounds like people are asking for more generic platform engineering that can be applied industry-wide.
Yeah, I think I just would like 99% of those problems solved. Like, don't make me think about the average amount of access a developer needs to a production database. There is probably a set of things they need to access to do with that database, metrics, number of queries running, probably need to be able to do updates, things like that. They probably don't need access to the actual data itself. And that is the same across most companies. So that's an industry-wide problem that you could solve with some kind of managed policy that exists that you can apply more widely.
But back to the problem of that's called something different for every single cloud provider, and then instrumenting them, creating some sort of Terraform or IAC that could then be consistent across all of them. If I need something special, that's even more difficult. So one day.
I mean, writing those policies to one cloud provider is hard enough, let alone across more than one.
No, and honestly, when I was at a managed service provider, that was one of the problems we had, where we specialized in hybrid cloud and multi-cloud solutions. But unless we custom wrote an abstraction layer on top to then convince our customers to buy in on, no one wanted to go through the hassle of having to learn 3 different clouds, because there's no write once, fit all, like we're talking about today. It's you have to write it for every single cloud. Not tenable.
So what you want is for you to know that thing exists and for your customers to not know it exists to make your life easier.
The next one I had in my mind was better local development. I think lots of cloud services, and again, I'll go AWS specific, but Lambda, Dynamo, S3, they are difficult to emulate locally. And I know there's projects out there that provide some level of emulation, but they're not often native to the cloud. So it's someone playing catch up. It might be Minio, it might be local stack. You're not great at emulating the cloud truly. So most people I've gotten advice from on this just say develop in the cloud, which is logical. But what that means is you've got slower feedback cycles potentially because it's going to take forever to deploy this thing, depending on what that thing is. Or, you're just paying inherently more. You're basically, all of your development lives in the cloud, and the interface with local development versus developing in the cloud, there is more friction and complexity to that as well. There is something quite nice about someone running stuff locally, being able to access everything and just play around more. So yeah, I think for me, better local dev experience, or else a better way into the cloud where it feels local. I don't know what it would look like, but that is a thing I would like to see improved.
All right. Let me start by saying I 100% agree with you. And I would love for that faster feedback cycle. However, the clouds are absolutely immense, and the number of services they provide is immense. I don't think there's truly a good way to write a project that could emulate that on smaller hardware. Even if you have a MacBook like M3 Pro, I think that'd be very tough to do. Now I'm with you though, because I'm having the exact same problem, except mine's with my authentication service provider, where they don't offer any kind of local dev situation. You have to use their SaaS platform, and therefore anytime one of the devs goes to spin up their local stuff, right, that's a token that counts against our yearly quota. And that could potentially be a lot of tokens consumed for local development that were intended to be used for a different environment. We don't want to burn through those. So I would like to see that. Faster development cycle, I think, is the way to go, or faster feedback cycle is the way to go. But yeah, the question is how do you speed that up from I write this to it's deployed? There are some tools out there that can do this. For example, Scaffold and Tilt. Those are, again, Kubernetes specific, but those are, I change a file in my local directory and it's immediately reflected to my Kubernetes cluster. So those are the kinds of things I'd like to see.
Yeah, I think for me, that's the way you solve this, right? Is you don't try and emulate the cloud locally, because that's just not going to happen. AWS has 200 odd services. Okay, you might only be using 30 of them, but emulating all of those locally and incorporating all of the changes that AWS deploys hundreds, if not thousands of times per day, it's just not going to happen. And I don't think you can create a realistic test environment locally. Maybe you can get close enough that you can catch some really obvious bugs, but I don't think you're going to get those edge cases. So for my money, I would rather focus on improving that development cycle and improving that, like you said, that feedback. How do we get something I've written locally deployed to a dev environment as quickly as possible? All the checks and balances in place that we know we want to have before that goes into our cloud environment, say security, whatever else. Do we shift that left? Do we make that a blocker for getting into dev? Do we worry about that later on? They're probably things you can overcome, but it takes a lot of investment in tooling and working closely with developers to improve that experience to get there.
I take it, though, that you wouldn't want to sacrifice the native service itself, because you might be able to achieve some of these things by, I don't know, we talked about open fares in a previous episode, sticking that on, I don't know, a microcates or whatever. I don't know open fares, but you see my point. You could build a stack that would run in the cloud and would also run locally if you had that as your priority.
You could, but what about all the dependencies, right? So, sure, if I was deploying to OpenFaaS on EKS in AWS, that's one thing, but I'm probably touching a bunch of other services around that in order to make sure that I'm doing loosely coupled applications that don't turn into massive monoliths. So you then very quickly get into the problem of, okay, well, how do I run my message queue locally in a way that replicates or accurately represents what I've got in cloud? How do I run, I don't know, Aurora locally? I could run Postgres on my machine, but that's not necessarily something like Aurora serverless with all of the various quirks that come with that. So I think you, again, very quickly get to the point where it's like, yes, I can run and deploy locally, and I've made those decisions where my application isn't using cloud native services for the compute, but all of the coupling and back-end data stores probably are using cloud-native services. So how do I emulate that? The answer is, if you want a bug-for-bug representation, you probably don't. You focus on making those feedback cycles and those deployment cycles less frictionful for devs.
I think this is something platform engineering tries to solve, but I think that I also would expect more from the clouds to make this easier. Like, you're solving the problem of ephemeral environments, Sean. Like, if there was a warm start ephemeral environment someone could define, and you change something locally and it pushes that up, and it's just a quick feedback loop, maybe something like that would be quite helpful. But at the moment, it does feel like we're really fighting with the tools to get something reasonable for engineers to get that quick feedback.
I guess on the flip side, what do the cloud providers have to gain from giving you this tooling? Say, if we take your developers have a bunch of friction and you employ people to overcome it. Has that made you question using said cloud provider recently? Or do you just invest in that tooling and make it work in the best way you can? So if a cloud provider were to invest 10,000 man hours into perfectly you being able to replicate Lambda and Aurora and S3 locally on your machine, is it any more likely that you would choose those services versus not choosing those services?
I don't think the fact that it's local matters, but the fast feedback loop would.
And there's a difference. And yes, like Gary said, I think it can be solved, but it is going to take a lot of buy-in, both from the developers and the clouds, on specific tooling and specific workflows. And of course, your workflow is not the same as somebody else's workflow. And so then trying to come up with a happy medium between all, no one's ever going to be happy. And like Gary said, it's not high on the priority list. They don't have a lot to gain from doing that already. It is tough, but I do think there's a third-party market out there for that. I don't think it's maybe for the clouds to solve. There are other companies out there doing stuff, DevPod, Tilt, Scaffold, that are trying to give you these quick feedback loops and deploy out as quickly as possible. We just need something like that for the actual cloud itself. I mean, heck, if you just want to run Terraform Apply, you can get pretty close.
Well, I'm going to come from a completely different direction and say cloud security and the hot mess that is the current CVE, understanding security vulnerabilities in dependencies and containers and all of the current processes around that. So broadly speaking, the way that your CVE system works is that the distributions or operating systems that you're using to take the pieces that you're putting in are keeping a record of where your vulnerabilities are in that stack. And depending on what different people report and how they write down what their versions are and what they map to in terms of CVEs, it can be extremely difficult to understand what vulnerabilities you have in any running version of anything. And so you have to trust effectively the operating systems to tell you what you want to know, and then the scanners have to try and parse all the different information from all of the different places. But what that means is that if you're not getting complete information from your operating system on the CVEs that are related to your dependencies, say they just decide not to report on those because they came from a particular place, then you're going to end up with less vulnerabilities, even if it's not secure, because they haven't put them in the list that then gets scanned by the scanner. So the whole system is very difficult based on the current system of security data from dependencies and from operating systems, and you have to make sure you trust your operating system in order to do that properly. So I would love, in my mythical world, that this was a solved problem, and if you were in fact running a less secure container, that you could see that you were running a less secure container, and that would then be something that showed up in your scanner rather than where we are today.
This is the first request I might have that doesn't make my job easier, but private compute in general probably could do with more of a noise being made about it. I just remember reading about Apple's private compute cloud and some of the, if we're going to do a tool wish list, how about things like non-privileged runtime access tools or private cloud compute nodes or was it like stateless computation frameworks? Like, we're not really talking about those. And the cloud is quite leaky and it's got lots of defaults that are not ideal for privacy. So I agree with you completely, but I'd nearly say maybe the model of the cloud is too open, and these sorts of things should be discussed more widely than some proprietary Apple paper they wrote.
You talk a lot about shifting security left in development models, right? How much of that should you reasonably be able to shift onto the cloud provider? You've talked about private compute and things, like in your use case, Shane, things like Bottle Rocket or managed AMIs maybe solve some of those problems. I suppose it depends on where are you happy as an organization to put your root of trust. And sometimes that's in the operating system. Sometimes that's in whatever managed service you're taking from a cloud provider. I think it's a really, really difficult problem to solve at scale. And that's why I guess we've ended up in the mess we're in.
Well, and increasingly, the chip vendors want you to put your trust in them. With the AMD SEV SNP or the Intel TDX technologies, where effectively what they're doing is saying if the chip says that this is all running encrypted in use, then you don't need to trust the cloud provider so much.
Yeah, because the large US corporates that make those chips have proven to be really, really trustworthy over the last 10 years, right? They've made no mistakes in terms of the way that they implement security features on those CPUs.
You mean the guys who ship test keys as actual valid keys for encrypted signing?
That's the people I mean. Those people are great. We should definitely trust them.
Test keys, please remove, could be a legitimate key. You don't know. Might just have randomly come up as that.
It's really difficult to know who to trust, is the bottom line. And I don't really know what the answer there is. There are so many different circles of trust in a given application that I don't think there's a good answer here. Understanding your threat model, maybe?
That's the answer. Zero trust. Don't trust anybody. Because we can put as much faith as we want in the operating systems, but something's going to fall through the cracks. But I feel a lot better about that if it's running in an unprivileged container. That would make my life a lot easier. Same thing. We can have scanners for days telling developers there's all these issues, right? But if you don't have some way to easily remediate that, developers are not going to spend the time trying to address the tech debt. That's not what they want to do. There are tools for this, but you got to be invested.
You've got to be invested, and you've got to understand your company's threat model, how a given alert affects your environment. Again, there are tools that do this. Wiz is one that I've come across quite a lot that supposedly makes a reasonable suggestion as to you have this security group that is this level of open. However, we know that it doesn't affect you because we know this other context, or you have a container with this vulnerability in, but we know that that's only used at build time and isn't executed during runtime of the container. There's a bunch of things that it can tell you and similar tools can tell you. But if your company is like super hot on, we cannot have any vulnerable code even in the image, then that's something that you kind of have to enforce, right? And that's what it comes down to. There are so many times I walk into an environment and I see there are 800 real baseline checks that aren't being followed. And I don't really know the answer to that other than you either need to go through them and resolve them or just decide that these things aren't a priority for you. Maybe you should decide that MFA on your root user on your AWS account is a priority for you. Maybe you decide that logging and versioning for your S3 buckets aren't a priority for you. Either way, you have to make those decisions and find some way of recording them, monitoring them, and as your threat model changes over time, going back and reviewing those things.
All right, well, we've all given you what's on our Christmas list and well in time for Christmas, so if anyone would like to provide, please do. Or if you would like to ask any questions or provide any feedback, you can do that at show@hybridcloudshow.com. A quick thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of this show or all the late-night Linux family shows. And sometimes you get episodes early. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.